Example 4. An ordinary annuity pays 7.44% compounded monthly. A person deposits $100 monthly for 30 years and then makes equal monthly withdrawals for the next 15 years, reducing the balance to zero. What are the monthly withdrawals? Okay, read through this problem until you have an understanding of what's being asked, okay, and then resume the video. All right, what's going on with this problem? Okay, this part A, the entire thing, encompasses the full spectrum of retirement. Okay, the person is doing the saving and the living off of the savings. Okay, so what I'll go ahead and do, okay, just like we did in a previous problem, we color coded the saving phase and then the withdrawal phase. Okay, so the person first is saving for retirement. Okay, I will highlight that in yellow. Okay, and then after that, they start withdrawing the money out of that retirement account. Okay, so living off the money is the second part. So that's the withdrawal phase. Okay, and I will highlight that in teal. Okay, so let's start reading through the problem again and highlighting what pieces of the puzzle correspond to each phase. Okay, so we know that the person deposits $100 monthly for 30 years. Okay, that is how they're saving or making contributions to their retirement account. Okay, so I'm going to highlight that part in yellow. Okay, and then after that talks about how they live off the money, how they make withdrawals out of this account. Okay, so then they make equal monthly withdrawals for the next 15 years, and that ultimately brings the balance of the account down to zero. Okay, so those are your two phases of retirement highlighted for you. Okay, the question itself is in the last part here. It says, what are the monthly withdrawals? Okay, that's what you're trying to answer. Okay, so once the person has entered retirement, okay, how much money do they receive out of their retirement account every month? Okay, so this problem, okay, there's a lot going on. You actually have to start off by figuring out what's going on during the savings phase. Okay, you have to figure out how much the person saves up for retirement. Okay, and then once you calculate how much is in the nest egg, okay, then you can use that information to figure out the amount of the monthly withdrawals. Okay, so we're going to start off, okay, with the first phase, okay, of saving money. Okay, so let's jot this down. Okay, so let's look at this phase. So saving money. Okay, so again, that's the part that we have highlighted in yellow. Okay, so how does the person save for retirement? Well, they deposit $100 every month for 30 years. Okay, so the money grows through these regular deposits, okay, and through interest. Okay, so what's going on here? Okay, the person is saving money, okay, through these regular $100 deposits, okay, and there are no withdrawals during the first 30 years. Okay, so if you remember, what formula do you use if you're saving money through regular deposits with no withdrawals? Okay, well, if you flip back to your formula sheet, okay, that is going to be the future value of an annuity formula. Okay, so I'm going to go ahead and write that formula down. Okay, we're going to use this formula to figure out how much the person saves during those first 30 years. Okay, all right, so let's figure out what the variables are and which one we're looking for. Okay, so the obvious ones first. Okay, the interest rate is 7.44%. Convert that to a decimal. Okay, and then the interest is compounded monthly, which coincides with how often the person is making a deposit every month. So is 12. Okay, they save for retirement for the first 30 years. So time is going to be 30. Okay, and let's see, so that leaves us with A and P. Okay, so remember, A is the account balance, P is the amount of each regular deposit. Okay, out of those two, we know the P value. Okay, the person is contributing $100 a month. Okay, we're trying to figure out the account balance. Okay, meaning at the moment they retire. Okay, how much is in that retirement account? Okay, all right. So let's plug everything in. Okay, so here we are looking for A. Okay, so I'm going to put in 100 times 1 plus 0.0744 divided by 12 raised to the 12 times 30 power. Outside of the exponent, you need to subtract 1 and then divide by r over m. Okay, so that's how you would set this one up. Okay, and then we're just going to go over to our calculator, okay, and punch this in. Okay, all right, so this formula, we've worked with it a few times before. Okay, so we know we need to start with the most complicated part first, okay, which is inside the brackets, and between the numerator and the denominator, the numerator is more complicated, so we're going to start there. Open parentheses, 1 plus 0.0744 divided by 12, close parentheses, raise this quantity to the 12 times 30 power, okay, get out of the exponent and subtract 1, okay? So this is the numerator, okay? We need to come back and divide this by r over m, so hit the division key, okay? R over m has to be in parentheses or it won't come out correctly, okay? So we're going to divide this, open parentheses, divide by r over m, close parentheses. This is going to give you the quantity inside of the brackets, okay? And now we need to multiply by the number out front, which is 100, okay? And so this is going to give us the account balance at the time of retirement, okay? So let's go and jot this down. This is going to be dollars and cents, so we are going to have to round this to the nearest cent, okay? So let's see here. This is the number that comes out of the calculator. And so now let's talk about rounding. Okay, so we've got 99 cents and then there's a 9 that comes after. Okay, so you've got to bump this up to actually the next dollar. Okay, so at the time of retirement, the person has $133,137.00 in their account. Okay. All right, I was about to circle this as the final answer, okay? But this is actually not the final answer, okay? Remember, what are we looking for, okay? We're trying to figure out what the monthly withdrawals are that the person can make once they're retired, okay? So what we've just calculated, okay, this is the account balance at the time of retirement, okay? This is not our final answer, okay, but we have to use this information in order to get our final answer, okay? So I'm out of room, so I'm going to continue on a separate sheet of paper here, okay? So where do we go from here, okay? So we know that after 30 years, this person has built up a nest egg of $133,137, okay? So the person at this point, okay, they retire, okay? So that means they are no longer contributing to their retirement account. Those $100 deposits have stopped, okay? So now they're going to live off of this nest egg, okay? So this money, okay, this $133,137, okay, that's the nest egg that these monthly withdrawals will come out of, okay? At the same time, even though money's coming out of it, whatever is still in the account is going to still earn interest, okay? So that's what you've got to remember. Whatever is still in there is still going to earn interest, okay? So at this point in time, once they retire, okay, what happens now is they start withdrawing money. So the annuity starts to be paid out, okay? So here we go. We're entering the second phase of retirement where the person lives off the money. We're in the withdrawal phase, okay? So on the next page, okay, so this is living off the money, okay, which is the withdrawal phase, okay? Well, what happens here, okay? The annuity is paid out, okay? So if you go back to your formula sheet, what formula do you use when an annuity is paid out? Okay, well, you use the present value of an annuity formula. Okay, so I'm going to go ahead and write this down. Okay, remember, this is the formula with the negative exponent. Okay, all right, so we need to figure out what we're looking for and what we know. Okay, so again, we're going to do the obvious variables first. Okay, we know that there is still an interest rate because the money that resides in the nest egg, okay, from which the withdrawals are coming, okay, whatever is still in that account is still going to earn interest. Okay, so we're going to use the same interest rate that we have been using. Okay, so if we go back to look at the problem, okay, it's going to be the same interest rate. It's going to be 7.44%. Okay, so let's see here. Let me write that down. So let's convert that to a decimal. Okay, and then remember, the person is going to receive monthly withdrawals. Okay, that coincides with how often the interest is compounded monthly. Okay, so M is still going to be 12 here. Okay, time wise, okay, in this second phase, okay, of living off the money, okay, how many years over which do they make withdrawals? Okay, well, if you read the problem, okay, they saved money for the first 30 years, and then for the next 15 years, that's when they're taking money out. Okay, so it's a 45-year process. Okay, so in the second phase, the withdrawal part, that only lasts 15 years of the 45. Okay, so time will be 15 years here. Okay, that leaves us with P and PV. Okay, one of these we know, the other we have to calculate. Okay, we are trying to, if you go back to the question, we are trying to figure out the monthly withdrawals. Okay, so the monthly withdrawals, okay, in that formula, P is the amount of each paycheck to the recipient. Okay, so we're actually looking for the P value here. Okay, so what is the present value? Okay, present value is the amount of the one lump sum that has been invested, okay, in order to pay out the annuity. Okay, well, what is the one lump sum that is going to pay out this annuity? Well, it's the amount of the nest egg. Okay, so in this second phase, this $133,137, that is your present value. Okay, at the time of retirement, okay, the value of the account was presently $133,137. Okay, so that would be the one lump sum that is going to be used to pay out this annuity. Okay, all right, so now that we've identified everything, we can plug it into our formula and then into the calculator, and we will know the monthly withdrawal that the person can make. Okay, so let's plug everything in. All right, so give me a second to just put this into the formula. Okay, so our exponent is going to be negative 12 times 15. Divide everything by R over M. Okay, and then let's go to our calculator. Okay, again, the formula, we're going to try to calculate what is in the brackets. Okay, everything in brackets is a number. Okay, so we're going to be able to get a number out. Okay, the numerator is the more complicated part. Okay, so let's start there. We're going to have 1 minus, open parentheses, 1 plus 0.0744 divided by 12. Okay, close parentheses, raise it to a power. The exponent is negative 12 times 15. Okay, and that's your numerator. Okay, we've got to carry all these digits. Okay, and then divide by R over M, which needs to be in parentheses or it won't come out correctly. All right, and this is going to give us the number in brackets. Okay, so this is the number that P is being multiplied by. Okay, so let's go jot this down. Okay, so let's see here. Whoops. So we're going to have on the right side, we're going to have P is equal to, or sorry, the right side is going to be P times this number we just got out of the calculator. And then on the left side, we still have 133,137. Okay. P is multiplied by this 108 point blah, blah, blah number, okay? So to undo that, we need to divide both sides by this number, okay? Whatever you do to one side, you have to do to the other. So let me squeeze this number in here. And then we can go to our calculator, okay? On the right, this decimal will cancel with this one and leave you with P, okay? And then now let's go to our calculator, okay? All right, so we're gonna get, let's see, here I need to use this previous answer, okay? So I'm gonna go ahead and hit 133, 137, and I want to divide by this 108.27 something number, okay? So either enter all the digits in or do second negative sign to call up the previous answer, okay? So this is going to be the amount that the person can withdraw every single month, okay? We need to round it to the nearest cent because it is a dollars and cents amount, okay? So let's go ahead and write that down, okay? So, oops. So let me erase this. All right, so out of the calculator came $1,229 and some change. All right, so let's go ahead and round that. We have 66 cents. A 1 comes after, so we need to keep it the same, okay? So this tells us that the person can withdraw $1,229.66 per month for 15-year period, okay? So that's how this problem works, okay? So you saw the entire spectrum of retirement here, okay? The first part of the question, we had to calculate how much the person saved during the first 30 years, okay? And then once we knew that information, okay, we could plug into the present value of an annuity formula, okay, to come up with this calculation of how much the person would receive every month in retirement, okay? One thing to keep in mind, I don't think I made it as clear in the previous example, okay? So the person will make these monthly withdrawals of $1,229.66 every month for 15 years, and the balance is reduced to 0 in the account after the 15 years, okay? All right, let's take a look at part B of this question.